So we have a tricky scenario. I don't have a straight wire. So in place of that, I have a wire which is bent. It's basically a rectangle. So my question to you guys is, see, magnetic field everywhere by default will be circular. Okay, with center being the wire. And here too it will be circular, here too it will be circular. So my question to you guys is, what is the direction? Right? What is the direction? And is this, are we looking at North Pole or South Pole? That's the question end of it. And here too, you need to answer a similar way. So basically, to answer this particular question, you need to figure out what is the magnetic field of this loops, right? Is it clockwise or anti-clockwise? Not what is the magnetic field, what is the direction of the magnetic field that is of this loop. Okay, these three loops and three loops, you need to find the direction. So once you know that, right, you need to answer if this particular thing, right, is it North Pole from where we are looking at, or is it South Pole? Okay, so if it's still not clear what we are talking about, so I'll explain it over here. So I have a wire, right, in this way. So I have a current maybe in clockwise, if not anti-clockwise, right? So if I happen to keep a piece of paper, so will the magnetic field go inward to this, or is it coming out of this, right? Something like this. Okay, so question is, from this point, this end, we are looking at it. So is it going inward or outward, provided you have the current flowing in clockwise for this and anti-clockwise for this. So if you're able to talk about if it's going inward or it's coming out, we'll be able to answer if it's North Pole or South Pole. So if this face happens to be north, the other face will be south by default. So don't get confused. Both north and south are there. It's just a point of view. Actually, same thing. If I flip it, I have this particular diagram. Does that make sense? Right? If I flip it, I have this. If I flip it, I have this back. Okay, anyways, so please pause and try to answer this question. So here we have the current moving in upward and to the right and downward and back, right? Not back, actually going to the negative terminal. So here it is up, left, down, and to the negative terminal. So if I apply right hand thumb rule, we can clearly see, right? Again, please see to that you hold the palm and fingers making an angle of 90 degree. So clearly it is going inward over here and it is coming out over here. So when you look at this, again, point your thumb. I'm trying to draw. I guess, yeah, this is good enough. No, not good. Not very, no. This is not it. I have to try to hold the wire now. So that's, if that is your thumb, then it will be something like this. Yeah, that's better. Right? So clearly again, below the wire, if this is the wire, below the wire, it's going inward. And above the wire, it will be coming out. Okay, again, remember, this is your wire. So this is your wire, and that's happening. And over here, if the same thing is used, to the right of the wire, it is going inward, and obviously to the left, it will be coming outward. Sorry, I am wrong. You can't use the same thing. It is the other way around. Right? So if I happen to point the thumb downward, I'm trying to draw again. Okay, palm will be that side. right? Something like this. So here it is coming out, here it's going in. So basically in this plane, if you guys look at it, the magnetic field is going in, is it not? Right? So something like this. Okay, let me show it. Let me actually select those two. Right, something like this. So if things are going inward over there, what end is this? This end will be, right? Think about it. This end will be what? This end will be north end. No, south end, sorry. So this end, what we're looking at is south end, right? Does it make sense? See, by default, if you find one, by default, all of it will be going inward. See, here we found that it is going inward to this inner space of the loop. So in the inner space of this loop, all the magnetic field will be going in. That is by default, it will happen. If you have structured this way, it will happen so. Okay. I'm sure you're able to answer this off without even thinking. But yes, try to use your right hand. Right. So try to make use of this. Okay. And figure out the direction of the magnetic field here. So clearly, I have to use this particular style of holding the wire so as to indicate that this is going inward and here it is coming out, right? In this inner loop of the wire, it is coming out. And here, okay, here it will be in this way, right? So here it will be out and here it is in. And by default, this also will be out, right? Inside the loop, it will be out. Okay, all this space is inside the loop. And that will be going in. So if things are coming out, this makes it, yes, a north pole. Not north pole, sorry, north. So basically something like this, right? You are at this end and these two guys or something like this. They're coming out in this way. So if things are coming out, what happens? It has to be the north end of the magnetic field, north pole. Okay, northern part actually. North pole also is right. Nothing wrong in that. Yeah. Okay, so this is something that you need to know and this will help. So think about a imaginary plane, something like this. There won't be, but you guys have to imagine separating this to space, you know. So in between the wire is what you have the paper. It can be a rectangle structure also. It need not be, it can be a cuboid basically, not rectangle. What I mean to say is it can be a cuboid. You know, for that thickness, you say you have a magnet, a very thin magnet. So even that will, how will it produce? It will produce a magnetic field going over there and coming to this end. Right? Does it make sense? So instead of a magnet, you have a wire which acts like a magnet basically. Okay, so we just created a bar magnet kind of scenario. You can imagine that you have a very thin bar magnet and we are trying to figure out the north and south end of it by looking at the current which is simulating the bar magnet. Okay, I hope you guys kind of liked it because this is the complicated version that it starts and it is not too much. It will end in, I think, two or three more videos. It will get over. So yeah, you need to make a note of this as well. Okay, draw everything. Like everything on the screen, you have to draw. It will help you guys.